Hey everyone, and welcome to another episode of CNC Basecamp. Today we're going to build a chair. Now chairs are a unique project. They can be a little intimidating and a little fussy. Sometimes there's a lot of angles, there's joints that are very small and need to be very precise, and techniques that we may not all be familiar with. One great style of construction that's pretty simple and has a lot of possibilities is a slab chair. Now in its simplest form, a slab chair is a slab seat, 4 legs mortised into that seat, and then a single slab mortised in to the seat. You can't get any simpler than that. But that simplicity is what makes it a great project. We can take that form and make it very elegant, make it fun, do all sorts of different things. And here's the best part. We're going to build a contemporary slab chair, which will look great in any home, and we're going to do the whole project on a 2x2 foot CNC machine. So stick around while we build a contemporary slab chair. Well, before we get started cutting parts, let's take a little tour on the screen here and look at our chair. So as advertised, you can see it's pretty simple. 4 legs, a seat, and 2 pieces that form the back. Let's take a look at the leg first. Now there's all sorts of different legs that one could put on one of these chairs. I'm choosing a very simple trapezoidal form because I want a very clean looking chair design. This is 1¼ inch ash. I'm using ash because of the prominent grain, although any good hardwood will certainly work well. There's a nice stout mortise on the end here, a full inch deep, and that's going to make for a very strong chair. Moving up, we have the seat. Let me flip it over here, and you'll see here are the mortises, 4 of them for each of the legs. So those are easy pocket cuts. We'll be cutting those a little deeper than the tenon, so they'll be about 1 1/16 inch deep. Looking at the top, we have 4 mortises for our back slabs. Now, interestingly, these mortises are cut at an angle. So I'm going to mount the seat at an angle so that the router bit into the seat slab at about 8 degrees. Not shown here on this rendering, we are going to be dishing the seat out a little bit, and that's a nice function that we can do with the CNC router. Last, let's look at the back slats, or back slab rather. You can see we have 2 nice stout tenons on the bottom, and each of these slabs is tapered. So we're at 1 inch at the bottom, and then we end up at approximately a 1/2 inch thickness at the top. In order to lighten the look and to add some visual appeal, there's a circle cutout. There are many different cutout options in this style of chair. We could choose a diamond. There's just all sorts of different things. We could also echo the shape in a little bit of inlay work or other piercings through the back slabs. But I chose just a simple circle, and I think it's really going to work well for us. In order to keep the 2 slabs registered to each other, I'm going to be adding a spline that you see here down the edge of each back. And that also makes for a nice little element, having that vertical line go all the way up the front of the seat and also visible on the back. So it's a simple chair, but that's what I want. I want contemporary, modern, but with a bit of elegance in a chair that I can make quickly and enjoy in my home. Well, everything is set up to begin cutting the legs. I'm using a 1/4 inch upcut bit, and this is 1¼ inch cutting length, which is a good size for most of the components that we'll be making today. I'm using a depth of cut of about 1/8 of an inch and a forward speed of approximately 80 inches per minute. Making the seat means 4 different operations. We're going to be cutting mortises on the bottom for the legs. We need to cut mortises on the top for our back slabs, I need to dish out the seat, and finally we'll do a profile cut to get the exterior perimeter shape. Now, since I'm going to have to move the slab several times to clamp and flip it over, I'm clamping a bar here to establish a reference line. I also have a mark here for the center of this bar, and I'm also going to extend a mark onto the center of my slab. And I'll do that on the other side as well. And that means as I move it, I can always just line the two lines up against this bar, and it'll be right in place. So I'm going to go ahead and clamp the slab down and get set up, and we'll go ahead and cut the mortises for the legs. Well, as you can see, I have the seat blank flipped over and angled, and that's because I'm getting ready to cut the mortises for the back slabs. Now, using my computer, I figured out how much of a height I would need to angle the back of the slab, and so I cut a piece of scrap wood and have it propped up. I'm zeroing the bed out on the back of each mortise, and I just did that by carefully lowering the bed down and doing it manually as opposed to using the plate. So with that, I think we're ready to go ahead and cut the mortises for the back slabs. With the mortises cut for our legs and for the back slabs, the next step is going to be to shape the seat, to give the seat a little bit of comfort. Now, there are really two approaches that we can use here. One is I could model the seat out in a 3D program. In my case, I use Autodesk Inventor, and then have Vectric 3D, which is what I use, go ahead and create toolpaths. Well, not everyone has 3D programming available to them, so there's another way. Let's do this in a 2D fashion. Let's take a look at the screen here. This is Vectric again, but as you can see, I've got a series of what look like topographic map lines on my seat. And there are 5 individual steps that I'm going to take, and they're pocket cuts, and each one goes down 1/16 of an inch. Here's my first cut. That encompasses the entire area of the seat that I would like to have dished out. Here's my second cut. As you can see, it's come inward a little bit. Here's my third cut, and you can see here we have a center section, which will be between your legs, which will be slightly raised. Fourth cut, and finally the fifth cut. Let's go ahead and take a look at our 3D view for that, and let me click through all the. You can see the overlay. It's quite a bit of cutting. And here we'll go ahead and preview all the tool paths. And let me tip this back here a little bit. You can see there are some ridges, but I'm going to be taking care of all those by sanding, and it's going to create a nice, comfortable place to rest on that chair. Well, it's time to finish up the seat. I've changed out the bit from this 1/2-inch core box that I was using to dish out the seat back to our 1/4-inch upcut bit for the final profile cut. I've got a piece of MDF underneath as waste, and I think we're all ready to go. So let's go ahead and wrap up the seat. Well, the next 2 parts that we need to make for our chair are the 2 back slabs. There's a right and a left. Now, each of these parts needs a little bit of prep work before we can cut the profile out on the CNC machine. And that prep work is to taper it. So take a look at this blank here. As you can see, it's 1 inch at the bottom and then tapers out to 1/2 inch up at the top. And that's going to help prevent the back from getting too heavy. It's going to give it a lighter look, make it a little more delicate. So, how can we go about creating this taper? Well, there are 2 methods. The first one involves using a planer. And what I've made here is just the simplest of sleds. It's a piece of MDF. I've used 1/2 inch and 1/4 inch plywood to support and capture this blank. As I feed it through, the planer will begin cutting here, and as I go deeper and deeper, that bevel will progress down the blank. Now, how far do we need to go? Well, let's get back to our finished piece here. As you can see, I have a line 3 inches from the base. That line represents the point where we transition from where the tenons are going to be, which we want to be full thickness, to the more visible portion of our blank, where we want the bevel and the taper to be. In order to know how far I need to go with my planing operation, I simply put some lines in front of this baseline. And as the planing progressed, it would eat up the lines, and when the lines pretty much disappeared, I knew it was time to stop. That's just an easy reference. There is a second way that you can make this long tapered bevel, and that's using your CNC machine. Now, you'd use the same setup as you see here, only this is going to be clamped onto our table. The board needs to be a little more securely fastened for the CNC machine. So what you can do is add a few blocks of wood to keep it from moving side to side, but I think the way to go is probably heat up your hot melt glue gun and just put a couple big globs of hot melt glue in key places to lock it in. At that point, you're good to go. Now, to set up your cut for this bevel, if we just did one large pocket cut, your machine is going to be air cutting for a considerable amount of the time. So to save time, what I'd recommend you do is to break up the cut into, say, 4 pieces. The first one, you'll go from about here to approximately 1/4 of the bevel, and you'll cut down about 1/8 of an inch. Your second one, you'll come out about halfway, and you'll cut down a full 1/4 inch from the start, and progressively forward. You'll go a little deeper here, and finally a little deeper at the end. And that way you can save a little bit of time. So we're all set up on our CNC machine to make the profile cut of the left side, so let's go ahead and proceed with that. So I'm still using the 1/4 inch upcut bit as I was before. Now, because this is beveled, we are going to be air cutting for a little bit of time until the bit lowers in about 1/2 inch and is engaging the wood all the time. Well, it's time to go ahead and start assembling our chair. Let me show you what I've done to the parts since they came off the CNC machine. Let's start with the legs. I used a router and added a 3/8 inch round over to all the primary edges. I also used a 1/8 inch round over to round over the corners of my tenon. And I did that because the 1/4 inch bit we used to cut the mortises out, well, it leaves a 1 inch radius corner. And this way it'll drop right in. There's also a dog bone at the base of each of these tenons. So that'll give us a little clearance to let this tenon slide completely into and against the bottom of our seat. So here's our seat. We've got mortises for the back, mortises for the legs. It's been shaped. After it came off the CNC machine, I took a 6-inch random orbit sander and smoothed everything out. So it's got a nice, comfortable feel to it. Really looks sharp this way. It breaks up the flatness that we otherwise would have had. And of course, we routed the profile. I also used the router with an 1/8 inch radius bit to soften up all the edges. And I used a rasp to go in here where our legs would be to kind of get that area behind the back of your knee and soften that up a little bit. Here we have our seat backs, 2 of them, round overs on all the edges. I also routed a 1/4 by 1/4 inch groove all the length of the inside edge of each of these slabs. And there's going to be a spline which fits in there, and that's going to help register the 2 seat halves together and keep them lined up. So with that, I think we're ready to spread some glue and start gluing this chair up. I'm going to start with the legs first. As long as we have the chair upside down like this, let me go ahead and point out one design element. Each of these legs is in opposition to the other, and that really gives us a lot of strength. If I had aligned these legs all straight, pointing front to back, or all side to side, we would really lose some strength because it would be a point of weakness where it could go back and forth a little bit. But by putting them kind of in opposition like this, where they face each other edge to edge at an approximate angle, it really helps to lock things together and makes for a very strong chair. And that way you can reduce the size of your legs a little bit. And one of the things that it does help us with is it means that we don't have to have a lot of structure in here, a lot of stretchers. And that's part of the fun of this chair, is that it is very simple. So we're going to start with the backs here. And what I'm going to do first is I want to go ahead and put a little bit of glue in the groove that we've cut for that spline. A little more convenient to do it now rather than later. Mostly I don't like to see glue squeeze out all over the place, but with structural joints like these that are so important, I kind of like to see a little glue squeeze out. Set that in place. Now, clamping chairs together is always a bit of a circus because there are very rarely are there flat surfaces that all are at 90 degrees to each other that we can clamp easily. So I'm going to employ a couple different methods here. One is that I want to be able to hold these two slabs together to pinch the splines. And for that, I'm just going to use some surgical tubing, which is a great clamping method for all sorts of utterly impossible situations like this. And all you have to do is just tuck it under itself to lock it in place. It actually adds a lot of tension, and what else can you use in so many different situations other than surgical tubing? It's really a great thing to have on hand. Next thing I want to do is I want to apply some downward pressure on these slabs for the back onto the seat. Once again, it's a difficult thing to grip, so here's what I'm going to do. I've cut a piece of wood with a slight radius to it that matches the top of the seat. In order to hold that in place, I'm just going to saddle it with two clamps. Next, I'm going to simply add a clamp on either side. And then as I get the second clamp in place, I can start adding some pressure. Now, because the chair is leaning back, the seat is leaning back, it tends to open up down here at the base, and we need to pull it forward just a little bit. And that's just because of the way that these clamps are. They're always going to tend to lean back a little too far. So in order to counter that, I'm just going to put a clamp and hook into our circle here, and then I've cut a little block of wood to go against the edge, this lower edge of my chair. And that gives the clamp a place to register against as I pull the back a little bit forward and true things up. So a couple things. One is little blocks of wood like this with cutouts really make life a lot easier. 2, think about how you can use the shape of your components and once again create some simple blocks, some simple cauls, and use clamps in tandem to get a good balanced squeeze on things. And then be inventive and use things like surgical tubing. And with that combination, pretty much any chair glue-up can be conquered. Well, thank you so much for joining me today for this episode of Basecamp. I hope you'll be inspired to try a chair of your own. The design possibilities are limitless. If you'd like to try this chair, the DXF files are available at our website. And remember, you can always use simple construction lumber to try it, modify it, see what you think. So, hope you'll join us next month for another episode of CNC Basecamp. You know, most of us use a 1 horsepower or 1.5 horse router with our CNC machines. And those routers we're going to see a lot of use, hour after hour after hour, carving signs, making furniture, doing all sorts of things. So, with that kind of a life, problems are eventually going to happen. Now, some router problems are lethal to the machine. For instance, if the commutator shorts out or if you have a bearing failure. Some router problems are pretty easy fixes. Maybe the cord fatigues the stress relief or you have to replace a switch. One thing that's definitely going to happen if you run your router long enough is that the brushes are going to wear out. Now when that happens, the springs that apply pressure against the brushes to help it push against the commutator, well, they just won't be able to apply that pressure. And arcing is going to occur between the brush and the commutator. Now that arcing can result in some erratic router operation and it can throw a lot of electromagnetic interference which may affect your CNC machine. So if your CNC machine starts acting strangely, don't blame it all on the machine until you think about your router and check to make sure your brushes are in good shape. Changing out the brushes is an easy operation. And I'd recommend you go ahead and purchase a set before you need them. That way they're there. I have 2 of these routers, and both of them are on their 2nd set of brushes. Now I expect I can probably get a 3rd set in them. Past that, I think the machine is probably going to be worn out and it'll be time for a new router. Along with having an extra set of brushes, good collet care matters. I have a precision collet on this machine, but regardless, we always want to take a little air and blow all the dust out and some solvent and really get up inside the cone, inside the spindle, and make sure that that is nice and clean. One thing that I got when I purchased this precision collet was this product, which is a collet care cleaner. And it has PTFE, which is a type of plastic, and boron nitride, which is a synthetic ceramic, which acts like graphite. These compounds are going to keep my collet operating smoothly. And if it's clean and operating smoothly, it's going to last longer and it's really going to grip that bit and give me better operation. So, 2 things you can do. Plan on replacing the brushes, plan on a program of good collet care, and you can more than double the life of your router.